Let's start with this problem. Find the mean, median, mode, and range of the following data set. Now, the first thing that I would recommend doing is arranging the numbers in increasing order. So the lowest number is 7, and we have 2 of them. After that, the next number is 10, and then 14, 15, 23, and 32. Now, to calculate the mean, what we need to do is we need to take the sum of the 7 numbers and divide it by the 7 numbers that are in the data set. So this is going to be 7 plus 7 plus 10 and so forth. And then we're going to divide it by the 7 numbers. So the mean is basically the average of those numbers. So the total sum that I got is 108. If you take 108 and divide it by 7, that's going to give you 15.4. I'm going to round it to 3. So it's approximately 15.43. So that is the mean. That's how you can find it. Now, what about the next thing? How can we find the median of this data set? The median is basically the middle number. So what I like to do is eliminate the first and the last number. And then working towards the middle, I'm going to eliminate the next 2 numbers until I'm left with the middle number. So as we could see in this example, the median is equal to 14. It's simply the middle number of the data set. Now what about the mode? What is the mode in this problem? The mode is simply the number that occurs the most frequently. I think I said that wrong. It's basically the most frequent number in the data set. And notice that 7 appears twice in this data set. So 7 is the mode. Now what about the range? The range is simply the difference between the highest number and the lowest number. So it's going to be 32 minus 7, which is 25. And so now you know how to find the mean, median, mode, and range of a data set. Now let's move on to number 2. Now this is going to be a similar problem, but it's not exactly the same. As you can see, we have 8 numbers in our data set as opposed to the 7 that we had previously. So let's begin by putting these numbers in order. So the lowest number is 11, and then the next number is 15, and then we have 21, and then 37, 41, and 59. So let's begin by calculating the mean. So the mean, represented by the symbol x bar, is equal to the sum divided by the number of numbers in the data set. So let's add up the 8 numbers. This is going to take some time. And then divide the sum by those 8 numbers. So we have 11 plus 15 plus another 15, and then 21, 37, 41, and 259s. So I got a sum of 258. If we divide that by 8, you'll find that the mean is 32.25. So that's the answer for the first part of the problem. Now let's move on to the second part. Let's calculate the median. As we said before, the median is simply the middle number. So let's eliminate the first and the last numbers and then the next two, and the next two. Notice that we don't have one number in the middle, but this time we have two numbers in the middle. So what should we do if we come across a situation? In this case, what you need to do is take the average of those two middle numbers. So you need to add them up and divide by 2. 2 plus 3 is 5. 7 plus 1 is 8. So 21 plus 37 is 58. And if you divide it by 2, this gives you 29. So 29 is the median in this data set. Now what about the mode? What is the mode in this example? Now, as we said before, the mode is the number that is basically, it's the most frequent number in the data set. But this problem is different from the last one because we have two numbers that appear twice, 15 and 59. So which of these is the mode? It turns out that they both represent the mode. So the mode is 15 and 59. So what we have is something known as a bimodal data set because there's two modes instead of one. It's not unimodal. Now what about the range? Well, there's nothing different about the range in this problem compared to the last problem. It's simply the highest number divided by the lowest number. So you could say H minus L. So the highest number is 59, as we could see here, and the lowest number is 11. So 59 minus 11 is 48. So now you know how to find the mean, median, mode, and range of a data set. Now let's talk about finding the quartiles and the interquartile range. So what I'm going to do right now is I'm going to make basically a number line with a beginning and an end. And let's say this number line represents our data. The lowest value is known as the minimum. The highest value in our data set is the maximum. Now we're going to break this number line into 4 equal parts. The first part is known as Q1. This is the first quartile. The second one is Q2, the second quartile, and then this is the third quartile. So let's say if the data was normally distributed, this would be at a 0% level, this would be 25, 50, 75, and then this will be 100. So you could see how the quartiles are related to each other respectively. Now, how do we go about finding Q1, Q2, and Q3? How do we do that? Q2 is basically the median of the entire data set. Q1 is the median of the lower half of the data set. And Q3 is the median of the upper half of the data set. Now the interquartile range represented by IQR, this is the difference between Q3 and Q1. So once you find Q1 and Q3, you can now calculate the interquartile range. Now the next thing that I want to mention is the ability to find or identify if a number in a data set is an outlier. So here's what you need to know. It's not going to be an outlier if it's within this range. If it's between Q1 minus 1.5 times the IQR, so that's the lowest that it can be, or the highest it can be is Q3 plus 1.5 times the IQR. So if you have a number that is within this range, it is not an outlier. But if you have a number in the data set that is outside of this range, then that number is an outlier. So let's work on an example. Let's say we have the numbers 7, 11, 14, 5, 8, 27, 16, 10, 13, 17, and 16. Go ahead and identify Q1, Q2, and Q3. Calculate the interquartile range, the IQR, and determine if there's any outliers in this data set. Feel free to pause the video and use what you know to try it. Now, as always, the first thing we should do is organize the data. The lowest number is 5, and then we have 7, 8, 10, 11. Perhaps it's best if we cross it off as we go along. And then the next number is 13, and then 14, 16, there's two 16s, and then the 17, and then 27. Now, what do you think is our next step in order to find the interquartile range and the three quartiles? What's our next step? The best thing to do at this point is to determine the median of the entire data set, which is going to be Q2. So we could eliminate the first two numbers, the first and the last number, and then the next two until we get a number in the middle. So notice that 13 is in the middle. So therefore 13 is going to be Q2. Now what I like to do is I'm going to get rid of this number for now. And I'm going to put a line between the left side and the right side. So I want to separate the lower half of the data set with the upper half of the data set. But the 13 is still here though, so just keep that in mind. So that's our Q2 value. Now, Q1 is the median of the lower half of the data set. So what is the median of those 5 numbers? The median is simply going to be the middle number of those 5 numbers. So Q1 is 8. Now what is the median of the upper half of the data set? Notice that the middle number is 16. So that is Q3. Notice that we have a total of 11 data points. And so that's why 13 is not included in the lower half or the upper half. Because if it was, one side will have 5 numbers, the other side will have 6. And that's why I chose to write it up here, so that the lower half is the same as the upper half. They both contain 5 numbers. Now let's go ahead and calculate the interquartile range, IQR. So we said it's the difference between the third quartile and the first quartile. So it's going to be 16 minus 8, which is 8. And so that's how you could find the interquartile range of a data set. Now, what about the presence of any outliers? So looking at these numbers, do you think we have a number that really stands out that doesn't belong? Right now, 27 appears to be very far off from all the other numbers. So do you think 27 is an outlier? Well, let's find out. So let's write down what we know. The presence of an outlier is based upon this range. It's Q1 minus 1.5 times the IQR to Q3 plus 1.5 times the IQR. So we know that Q1 is 8. And the interquartile range is also 8. Q3 is 16. So this is going to be 16 plus 1.5 times 8. What is 1.5 times 8? 1 times 8 is 8. 0.5 times 8 is 4. 8 plus 4 is 12. So this is going to be 8 minus 12. And this is 16 plus 12. Now 8 minus 12 is negative 4. And 16 plus 12 is 28. So now looking at what we have, is 27 an outlier based on its range. Because 27 is between -4 and 28, 27 is not an outlier. Now, if we had 29, that would be an outlier. So now you know how to determine if a point is an outlier within a range. Now let's talk about how we can create a box and whisker plot. The reason why we want to talk about this now is because it's related to the values of Q1, Q2, and Q3. So typically, a box and whisker plot looks something like this. Assuming if there's no outliers, this is going to be the lowest value. On the right, we're going to have the highest value, or the maximum. And then this line here represents the value of the first quartile, which is the 25th percentile. In the middle, we have Q2, the second quartile, which is the 50th percentile. And then this is Q3, the 75th percentile. And so that's the basic shape of a box and whisker plot. Now what about if we have an outlier? Let's say if we have one to the right. Then this will no longer be the maximum. The outlier is shown as a point. It's outside of the box and whisker plot. Now if it's on the left side, this will no longer be the minimum, and that will be the outlier there.